So while the last video I did a setup guide for the Huvud board with the Waveshare can hat, while I was really excited about that, this is really the video that I was trying to get to because it is so exciting what Arksine has done. Arksine is the developer of Moonraker and has contributed a lot to Clipper over the years, and over the last few weeks he has developed a CAN-based bootloader for some of the common ST chips. What this means is, for the Huvud board, up until now, every time you needed to update it, you have to disconnect power, put the boot jumper on physically, reconnect power, connect a USB cord, flash the device, disconnect power, disconnect the USB port, all these different steps every single time you need to update Clipper. And this is just a pain, because if you update Clipper and then by accident have to flash all of your microcontrollers, it can end up being a 5 to 15 minute endeavor just trying to go through all the process depending how accessible your Huvud boards are. With this CAN bootloader, it is a single command from the command line to flash the board because the bootloader handles going to bootloader, flashing the application, and exiting bootloader all by itself. No user intervention required. So today I'm going to show you how to take the setup we had in the previous video and then upgrade the bootloader on the Huvud board to the CAN bootloader. Before we get started, we need to make sure that our Clipper version is new enough in order to use the CAN bootloader. In this case, my version is 4.19, which is fairly new. As of today, it is the latest version. So before you get started, just go ahead and click check for updates, and then if there's any updates necessary, just make sure that everything is up to date. The first step to get started is to clone the CanBoot repository onto our Raspberry Pi. This is what generates the CanBoot bootloader bin file that we flash to our device. In this case, there's a very simple set of instructions here. We'll copy these commands, which is cloning the Git repo onto our Raspberry Pi. Then we will go to the CanBoot folder and run a make menu config, which is very similar to the Clipper one, except this is to generate the CAN bootloader for our device. In this case, with the Huvud, it is a STM32F103 with an 8 MHz crystal. In this case, we want to use the PB8, PB9 Canbus with a 250,000 in my case for the bus speed. And for CanBoot bootloaders, we use an 8 kilobyte instead of a 2 kilobyte offset. So be sure to always check this to make sure you're not flashing the incorrect version. The rest of the settings we can leave as is. Do Q to quit, yes to save, and then we can do a make clean and a make. Next, we need to grab the CanBoot bin file that we just generated on our Raspberry Pi and transfer it to our desktop. In my case, I'm going to use WinSCP for this, but with other operating systems such as Linux or Mac, you may use a different program. I'll click New Site. In the hostname, I'll put v1000.local. Username is Pi, and password is whatever you have set. Here we will click yes, and now we're in. We'll double click on CanBoot, out, and then download canboot.bin to our desktop. We can close out of this. For this next step, we're going to need an ST-Link. And these are really available on Amazon for $10 to $15 or on AliExpress for less than $5. It's really handy to have around just in case you ever need to update a bootloader or flash a chip that may have been bricked. And there's so many ST chips throughout the industry, it's just good to have one on hand. There's only 5 wires you need to connect: 3.3 volts, ground, SWDIO, SW clock, and reset. You can just follow the pinout on this diagram. This diagram is the same for both the 0.61 and 0.5 models. It's really simple to connect this device. All we need to do is disconnect power from the Huvud board so it has no wires connected to it. And then in this case, I have the ST-Link V2 with a pre-made harness I made from the diagram. I'm just going to connect that to the debug pins. This is really handy. I have so many Huvud boards that it's nice to have a pre-made harness that I know is just correct because I can repeatedly use it every time. Next, I'm just going to pull this extension USB cable off the side and plug in my ST-Link. Now the ST-Link is connected to my computer and the Huvud board is connected to the ST-Link. I've downloaded two ST programs here because I've found that sometimes one of them works better than the other, even though they're both different versions of the same thing. The first one is the STM32Cube programmer, which is the latest version of this program, and then there's the STM32 ST-Link utility, which also works. I'm going to show you how to flash the CAN bootloader with both of these programs so that you have the steps you need in case you need to use one or the other. If the first one works for you, then you don't need to flash it again with the second program. With the STM32Cube programmer, we'll go ahead and see in this top right corner where it says ST-Link, make sure the ST-Link is selected, then hit connect. Everything worked properly, so we're going to go over to this tab, do full chip erase, which is really important. If you do not do this step, then the Clipper application file may still be there and the unit may not go into bootloader appropriately. It needs to be able to go into bootloader for you to see the UUID. Next, we're going to go ahead and pick the Canboot bin file that we downloaded from our Raspberry Pi just a minute ago. Then hit start programming. That's all there is to it. We're going to hit disconnect. And at this point, our Huvud is ready to go. We don't need to do anything else. But since I want to show you both programs, I'll click this one, go Target, Connect, Target, Erase Chip, then File, Open File, canboot.bin, Target, Program and Verify, and then Start. And that's it. Same thing, is really quick and easy, it's very fast. Now that we have flashed the bootloader, we don't need the ST-Link anymore, so I'm going to disconnect it from the Huvud board, and I'm going to connect this device using the 4-pin connector here, the same one I was using before. I'll bring the Raspberry Pi back into the picture here. They're both on and powered up. Now we're back at our SSH window, and I pulled up the bootloaders documentation section from the Clipper webpage. And we'll see here we have STM32F103 with CAN bootloader, which we just installed. And so we can find the UUID using this command. First of all, we will need to do cd clipper lib can boot. If this doesn't show up in your Raspberry Pi or your SSH window and says file not found, be sure to go ahead and make sure again that you have the latest Clipper version by doing a git pull. In that case, you may need to go back through and do some more configuration. Next, I'm going to copy this command, right click to paste, and we see that we found our UUID again in this condition. So we can go ahead and flash Clipper firmware using this bootloader. First of all, though, we need to go back and make a make menu config for Clipper. So we'll do cd clipper make menu config. Then we'll verify all these settings. This time, instead of using a 2 kilobyte bootloader, which is the default bootloader for Huvuds, we go back to the 8 kilobyte bootloader. And you'll want to double check if this ever changes in the future. Just be sure to look at the Huvud documentation to make sure that you're choosing the correct bootloader. However, in this case, we just flashed the Canboot bootloader and we know that it has an 8 kilobyte offset. Other than that, everything's good to go. So I'm going to press Q, Y, and we're good to go. So make, clean, then make. I'm going to come back over here because I know I've stored my UUID right here, which is the same as what is up a little bit further in the SSH window, but I know I'm going to need that in just 1 minute. And it's just about done here. Again, we need to go to cd lib can boot. And now we can copy this command. Note I'm not copying this last piece because this is the UUID that is unique for my Huvud board. It'll be different for each person. So I'm going to right click and copy, do a space. I'm going to come over to the can UUID, copy and paste. And you'll see it's also the same value that is up here. I'm going to go enter. It's detected the board and it's flashing the updated firmware. Then it's verifying it. And that's it. So now we have a board that can be flashed with updated firmware anytime using one single command. So we generate the firmware and then we flash it. No need to put the boot jumper or anything like that on the device. It's really convenient. The final thing is now that it's all flashed, we're going to do a firmware restart. And we'll go to the machine and we see that Klipper has pulled up the device here and it is connected. There's one thing that people get hung up on though, and it is trying to see if the device is still there after you have flashed Klipper to it. And from this we see that we have connected to it appropriately, but if we run the two commands that people most likely use, the first one is in the Canbus documentation in Klipper. We'll copy this and paste it. It finds no UUIDs. The second one, if we go to the bootloader section, if we do this, it also doesn't find any UUIDs because both of these commands only pull up a UUID if the device has not gotten initialized by Klipper. So if we go back to this config, this MCU showing up right here, that is our Huvud board, shows that it has been initialized. If we go back to our printer config, and in this case I'm just going to copy this ID that doesn't actually exist, and then we comment out the correct UUID and then do a save and restart. Klipper is going to try to connect to a device that is not there, and so the device will not be initialized. So we can run those two same commands again, and it finds it there, and then the second command, it finds it there. So now it is showing up. So again, if it doesn't show up when you search for it, then you just want to make sure that you haven't already connected to it in Klipper, because if it's defined in Klipper, then it won't show up when you scan for it. So I hope you all are excited about this as I am. This is a big quality of life improvement for me and for all of us, because when I hit the update Klipper button, sometimes I don't know if I'm going to have to update my Huvud board, and when I do, it's always a pain. I know I timed it. It's less than 5 minutes if everything's right there in front of you, but I normally have to go hunting for a USB cable or a boot jumper, or trying to reach into weird places to find the correct pins on the toolhead board, and it just is a pain every single time. So if you find this information useful and this added functionality useful, I've added a link in the description to Arksine's kind of like support page. It's not a Patreon, it's just a one-time donation. I would have donated to him for this feature because he's put in so much work to this as well as Moonraker, and just really support the people that help us have more fun with 3D printers. So I'm really excited about this, and I have one more video after this that will tie everything together that just makes updating your boards such a nice experience. So hang out and expect for that video here shortly, but I hope you all have a good one.